Hello everyone. In this video, I'm going to be talking about a Kaggle competition that I did, and I'm gonna explain how I did it, and I'm hoping that this can be a template for other people who want to do any sort of machine learning projects. This can act as a very simple example of how to do so. So the first thing we do in a project like this is we read in the data. So downloading it from the Kaggle Space Titanic competition board. You can guess the training data and the test data. And the training data looks like this. It has your passenger ID, your transported. This is our target, and then in between here we have 12 features or things we're going to use to try to predict whether our um, whether our person was transported. Then what we do once we've made a machine learning model um, that can guess accurately whether someone was transported, then we take our test data and where we actually don't know if they were transported or not, and we attempt to guess whether they were based on all the other features here. So first thing to do, very simple description. If you look closely at like the quantiles, you can see that a lot of them are very heavy-tailed. Um, and then the first thing we do after we've just done a quick look, make sure there's nothing crazy going on, is we look at the data and we notice certain things. Like for example, in this data set, we have this cabin column. And if we look at this cabin column, you can see it's basically split into three different sub features for the deck, the room number, and the side. So what I've done is I've split this cabin feature into multiple different features, the room number, um, yeah, the deck, the room number, and the side. And then I've removed the cabin feature because it's all contained within these three columns. And now what I do is I take my train dataset and I've split the features, the things we're going to use to predict whether someone was transported or not, into three different categories. So the first category is categorical features or cat features, and these are your home planet, your destination, what side you're on, and the deck. Then our numerical features, these are ones that can be represented basically as numbers. Um, so your age obviously is a number. Room service, how much you spent on room service, spa, all these are pretty clearly numerical information. And then the Boolean features are the ones where it's kind of like a yes or no. Whether you went into cryo sleep, that's just like a true or false. There's no real third option. And then whether you're a VIP. And we add all these lists together to get our entire feature list. We define our target here as the transported column, and then we define our passenger ID here. The first thing to do is really just create some plots or create some basic analysis first to see what the data actually looks like. So here is a bunch of different plots of all the different numerical and Boolean features and the target regressed on each in a scatter plot, and then it's colored in whether the person survived or not. So the main things I noticed about this, or the easy takeaways, are that a lot of the data is heavy tailed. So if we look at, say, the shopping mall ones, you can see there's a lot of very extreme outliers here, and then most of the data in the shopping malls kind of hangs around the very left here, which basically means most people didn't really spend that much at the shopping mall, and then a few people spent a bunch of money. And so how this data structure is going to affect how a machine learning model learns on the data. And the second thing is we can see immediately some pretty obvious correlations. For example, how much you spent at the spa. If you spent more money at the spa, you probably were less likely to survive, which is why all these blues are here. If you spent more money on the VR deck, then you were less likely to survive. And if you didn't spend your money that much, you are much more likely to survive. And then obviously you could draw more out of this, but I'm just going to move on. And then what I did is I did a simple correlation, a simple Pearson correlation between the target and our numerical and Boolean features. And obviously you can see here that a lot of them are um, very highly correlated. For example, cryosleep. If someone went into cryosleep, then they were then that's 0.45 correlated with the target. The spa is inversely correlated with whether someone survived. So is how much room service you ordered. And then you can't really do this analysis with the categorical data. So what I did for the categorical data then is I did a group by, nice and simple, and I just got the mean, so of how many people survived. And so, for example, this figure here, this 0.658, this means that of the people that were from Europa, whose home planet was Europa, then 65% of them actually got transported, while the people whose home planet was Earth, only 42% of them got transported. And similar here with the side of the deck you are on, led to notably different transporter rates. And then here, I've done a few histograms. These not only show the discrepancy between the people who got transported or not, but they also show the discrepancy where some categories are significantly more common. For example, Earth's way more common than Europa and Mars. And something similar with their destination or where they're meant to go to, where the vast majority of people were meant to go to Trappist, and only a small minority were meant to go to the other two destinations. Also, you notice the difference in the number of categories. So this one has about 8, while these two only have about 3. The next thing we did after we just looked at the data, did some simple analysis, is we noticed that there are actually NA values in our training set and in our test set. And these have to be filled in before we feed our training set into the machine learning model. So there are many ways to do this. I think a very common one is k-nearest neighbor. You might even try to use other features to predict using another machine learning model to fill in the NAs. But what I did, probably the most simple way you can think of, is that I filled in the values with the median and the mode. So an example with this is if there's a passenger and we didn't know their age, then we would say, okay, well, the average age or the median age on um, this ship is 30. So we're going to say that this person's 30. We're just going to guess it. Or, and obviously that doesn't work for categorical features. We use the mode. So I say, um, okay, most people, for example, if we didn't know their home planet, we say most people are from Earth. So I'm going to fill in their home planet is Earth just as a guess. Um, obviously, and this was the way that I just removed all the NA values. Then finally, once we've kind of looked at the data, we've made it nicer to use. We want to um, do some small manipulation to it again before we pass it into any sort of machine learning model. So I used Cat Boost as the library for my predictions, and they don't want you to feed in for the target like true and falses. So I translated it into trues equal to one, or and then falses to zero. So it's basically just a really simple mapping from one to the other. Then I split my data set into the target, which is our zeros and ones column based off the transported column, and our features, which are, of course, all our feature columns that we're trying to use to predict the target. And now what I do here is I set up my parameter grid. It's extremely small in this example because I just wanted it to be a test example. If someone were to recreate this and trying to use this to have the best score, they'd probably want to have a much bigger space of hyperparameters. Secondly, adding, you need to specify for the cat boost classifier, you have to specify your categorical features. And then what I use is I use a grid search CV from the sklearn library. So now that we've initiated our grid search CV with our machine learning model and our parameter grid, we have this object with some very useful functionality to train a model and do k-fold validation. So once we set up um, our k-fold validation object, then we use it to fit our x-train, our features, and our target, our y-train. And what we get are our predictions. And simply, we look at the average of our predictions of a bunch of different folds, which is basically just you split the data in a bunch of different ways, see how it works in all these different ways, all these different training test sets or sub training test sets. And then you average it out and say which one performs better on average. And we see the one with a depth of 8 tends to perform better on average. So I picked that one. And then for simple test and prediction on the training set, we get about an 81% accuracy. But obviously that's a bit overfit because it's the same training data to test. Then finally, after we've gotten our train model and we've tried to pick the best hyperparameters, we do a bit of data manipulation on a test set, the same as we did on the train, and then we get our predictions. And finally, after we've gotten our predictions, which look like this, we save it, and then we've done. We've taken our, we've made our guess, and then we can either try to make it better by, or we can just submit it and say we're happy with it. So For this example here on the test set, I got about 80%, so 80% correct on the test set, which is good because it's quite similar to what you got on the train set, which means it's not overfit. And that's, I think, if I look at the scoreboards, the very best person got 90%, 96%, which is crazy. Then most people behind that got 82 as the second best estimates. And then I'm down here at about 600, and a bunch of people are tied with me, um, at about 80%. So if I were to make this more expansive, I've kind of written a few things, but obviously like machine learning to predict a feature, you can do it forever. But a few simple things is that I really didn't use any other models. I didn't look at the data probably sufficiently thoroughly to see what models might have looked best, might have worked best with this data set. And I didn't really train the hyperparameters. I really just tested one. There are multiple different ways to infer missing data. K-nearest neighbor and like 100 different variations of that are the most common ones that I've heard of, but I'm sure there are way more. One thing is that there's always like information kind of hidden um, in the test set. So it read here in the description of the problem that the second part of the ID was actually, or the first part of the ID was the group that they were traveling in. And then the second one is the number within a group. So what you could do, a few ideas you could do with that, you could try to predict their age better, maybe by the group they're in. Maybe you could use that for the inference of missing data by saying, okay, all these people in a group are from Europe, and we don't know this other person who's in the same group's um, planet of origin. Let's guess they're from the same planet. Stuff like that I really didn't look at. And also I didn't really look at the names field at all. So people with the same last name might be correlated in some way. I didn't standardize the data at all, which looks like this. And it's very common in machine learning because machines kind of find it easier to work with standardized data rather than normal data that we use. Or I can normalize it so that the data set is between um, so that all the features are between a range of 0 and 1. This might make outliers less important because the max difference would be between 0 and 1. While in our example here, outliers are probably quite influential because they're so much bigger than everything else. I think that's a really good place to leave it. Obviously, there can be a lot to expand upon, but I hope that if anyone else wants to engage in a similar project, this is a helpful template for doing so. Thank you for watching.